So what's up guys? Again welcome you all to my channel Abbott Academy. So this time we are going to do a very interesting topic. Yes guys, so today we'll be going to do projectile motion. So let us quickly come to the projectile motion. So here I'm drawing a diagram to present the projectile motion. Suppose these are our x and y coordinates. Let us first understand about projectile motion. That what is it is. Now consider this, I'm throwing a ball. I'm throwing a ball upwards at an angle theta. So this is my direction of motion at an angle theta. So with the initial velocity of the ball is u. Now let us plot the trajectory of my ball. That is the path taken by the ball. So the ball will go upwards like this, like this, like this, like this. So the ball will go upward like this and thus eventually come to rest after covering the distance. Okay. Now why does this path was a parabola and why did the ball come to rest only? We'll answer all these questions and the various derivations involved in the projectile motion in this video. So stay tuned guys. Let us go quickly to the derivations. So now let us come to the derivations involved. So firstly, let us talk about the time of flight. Now for this, to understand it easily, let us break the velocities into its two components, that is vertical and horizontal component. So this is our velocity u inclined at angle theta. Now the horizontal component will be u cos theta and the vertical component will be u sin theta. Okay, so these will be the two components of the velocity. Now, at the maximum height, we can clearly see that only the horizontal velocity is there. That is, u cos theta will be there, and the vertical velocity will be nothing but 0. So, by using this information, we can write. So, by using the equation v is equals to u plus at. So here for the vertical motion, I can write that the final velocity will be 0. The initial velocity for the vertical motion is u sine theta, and the acceleration a will be nothing but gravity that is acting in the downward direction. So let us consider the upward direction as positive and the downward direction as negative for our sign convention. Now into time, that is t. So it will be minus u sine theta is equals to minus g into t. Now for the simple equation, just cancel the minus sign and t will be u sine theta upon g. Now this is not the time of flight. Why? Because this is the time when the projectile reaches its maximum height. But we have to calculate the whole time. So the whole time, that is denoted by capital T, will be nothing but 2u sine theta upon g. So this is our the time of flight. So let us get into. So this will be our time of flight. Let us move to the second derivation. Now, as we derive the time as 2u sine theta upon g. So let us keep it aside now. So now we will be talking about the very important thing, that is the range. So now let us talking about the range. So the range is the horizontal distance traveled by the projectile. So this will be our range. Now let us apply our common sense, and as you can see that the if we talk about the horizontal velocity, then the horizontal velocity is only u cos theta, and the vertical velocity will not at all contribute in the horizontal distance. So the velocity in the horizontal will be u cos theta, and that will be required for covering the range. So the range will be, as we know that speed is equal to distance upon time. So as you can know that speed is equal to distance upon time. So distance is nothing but speed into the total time. Now just substituting the values. So d is nothing but the range, the range of the projectile will be the speed of the projectile, that is u cos theta into the time. Now let's just substitute the values in this expression and let us derive our answer. So as we wrote that, range will be u cos theta into the time interval. So on substituting the values of range as u cos theta into the time, we get this expression. Now let us simplify this expression. On simplifying, you will get u square sine 2 theta upon g. So yes guys, this is our expression of a range. So this beautiful expression u square sine 2 theta upon g. So the sine 2 theta came because I concluded 2 into cos theta into sine theta. It becomes sine 2 theta, the formula of trigonometry. So this is the formula of range, that is the horizontal distance that the projectile will cover is u squared sine 2 theta upon g. So now talking about the maximum height attained by the projectile. So in the maximum height attained by the projectile and for the vertical motion of our projectile, the vertical velocity is responsible. Yes guys, so we'll be using u sine theta to derive the expression of the maximum height. Now, as we know that h is equals to ut plus half at square, with this s is equals to ut plus half at square. Now, we'll be using this expression for our vertical motion. Now, for the vertical motion, s will be nothing but equal to h, and the initial velocity will be u sine theta into time. Now time will be not the total time of flight, it will be half the time of flight, because the projectile takes t by 2 seconds to reach this maximum height. So the projectile takes t by 2 seconds to reach this maximum height, t by 2 seconds to reach this, and then t by 2 seconds to come back. So it will be u sine theta upon g plus half into, it will be minus here. Why? Because the gravity is acting downwards. So minus half into g into u square sine square theta upon g square. Now as we wrote this expression on our previous page, let us simplify this. So I can cancel a g, so the power reduced. Now it will become u square sine square theta upon g minus u square sine square theta upon 2g. Taking the LCM, I will get u square sine square theta upon 2g. So this will be our expression, simplified expression. So this will be our final expression for our maximum height reached by the projectile. Let us make a box here. So in this video we derived all the expressions and the various derivations involving the projectile motion. So guys, if you like this video, so please don't forget to subscribe my channel Appet Academy and stay tuned for more such educational